Linear systems. To first start about talking of these linear systems, we need to take a look at what you might just think of as some graph paper, but this is actually a really special graph. It was created by a French mathematician named René Descartes, and it's known as the Cartesian plane. Now, there's some key points and key parts of the Cartesian plane that you may have seen in the past, but you may not have, so I'm just going to quickly go through some of them. Right at the center of the Cartesian plane, there is a point, and it has a special name. It's called the origin, and it has some coordinates. In this case, it's 0 and 0. And the reason it's 0 and 0 is because there's actually two different axes. So this blue line here is an axis, and this green line up and down here is another axis, but together those are known as axes. This one being the x-axis and the up and down one being the y-axis. And René Descartes realized that he could describe where things were using a grid system like this. So if you had x is 3 and you had y is -8, you would end up with this point down here at 3 and -8. So it was always the x value and then the y value next. So you can see how these axes split the Cartesian plane into four parts. One part might be this top right-hand area. That area, each of those four parts, is known as a quadrant. So this is quadrant 1, and this is quadrant 2, and René Descartes defined this one to be quadrant 3, and this one's quadrant 4, and they're generally written using Roman numerals like I did to indicate which quadrant is which. Now, the systems that we were looking at last day, those equations from last day to describe the patterns in the tables, most of those are known to mathematicians as linear equations. And the reason that they're linear is because if you were to graph all of the points, all the coordinates on a Cartesian plane, it turns out that the line that's generated is a straight line. So today we're going to take a quick look at linear equations and how you generate those straight lines a little more quickly than just plotting every single one of the points and joining them together. So any straight line that you get, and linear just means straight line, any linear equation that you get can always be written in this form. And this is a key formula for this year and future years. And it's y equals mx plus b. And it's got some certainly distinct parts to it. X and y are the variables, and they tell you how far left, right, and up and down to go in your Cartesian plane. The m value here is known as the slope of the line, and slopes, as we'll see in a few minutes, determine if the line goes up to the left or down to the right or is flat or not flat. We'll take a look at the slope a lot more in this unit. And this b value here is known as the y-intercept. And the y-intercept and the slope are massively key in determining how these graphs look and how we go about putting an equation onto a graph fairly quickly. So let's take a look at an example of that. I'd like to try and graph this equation, y equals -3/4 x plus 1. So one way that you could do this is you could make a table of values, which is basically those pattern tables. So you could say, well, what if x is equal to 0? Well, -3/4 times 0 plus 1, then y would be equal to 1, and you could graph that point. And then you could say, well, what if x is equal to 2? oh, you're going to end up with some fractions and they're not going to work out very nicely. So an old method, and actually even when I teach higher level math courses than grade 8 and grade 9, which is where we first see making up a table of values, even when I teach higher level courses, we sometimes still make up table of values to help us. So certainly welcome to make a table of values to graph these sorts of things, but it is really slow compared to the method that I'm about to show you. So let's get some space here and some graph paper, and I'll show you the essentially 3 or 4 steps that it takes to graph this very, very quickly. So there's my graph paper, and here's the steps, and it'll take a little bit to write out, but they're actually very, very quick. So the first step is to graph or put a point down where you have a y-intercept. So in this case, remember y equals mx plus b. This plus b is your y-intercept. So in this case, the plus 1 is your y-intercept. And the y-intercept is found on the y-axis at plus 1. So you go to plus 1 and you put a dot. That's step number 1. Then we can go to step number 2. And step number 2 is starting from your y-intercept. So this is a mistake that a lot of students make. They don't start from the y-intercept. You must continue the patterning, the next step, from that y-intercept. You now use the slope to find more points. So this m value is the slope, and in this case that's this value here. So the question is, how do we use that slope? So that slope, or the m value, how do we use that to find more points? Well, the slope is equal to what we call rise over run, or as we saw last day, the change in the y direction, and y goes up and down, compared to the change in the x direction, and the x direction goes left and right. So the change in the y direction is down 3. So you start from your point, and you go down 1, down 2, down 3. That'd be about here, and then you go right 4. So negative 3 over 4 means down 3 and right 4. So down 3, 1, 2, 3, 4. And there's another point. Down 3, 1, 2, 3, right 4. And I can't keep going because I go off of my graph. But this is down 3, right 4. Down 3, right 4. Well, if you can go down 3 and right 4, you should be able to go the other direction. So that would be up 3, but so that would be like plus 3, and then left 4, and that would be minus 4. And notice negative 3/4 and positive 3 divided by negative 4 are the same, negative 0.75. So I can go up 3, and then I have to go to the left 4, and I can go up 3 and to the left 4. And you'll notice, if I get rid of these arrows, you'll notice that there's a nice looking pattern between all of these dots. So that's kind of your check. You should have a nice straight pattern here. So now we have to do basically the last step. Just connect these dots with a straight line. So there's your reasonably straight line. Now hopefully you use a ruler. It's a little hard for me to use a ruler on this computer, but there's my straight line. And then I add arrows. And the reason that I add arrows is this graph, this Cartesian plane ends, but the line doesn't. This line and this pattern go on forever. And that's how you graph a line. It's much, much faster to do this. Graph the y-intercept, and from your intercept use the rise over run, use that slope, and then connect the dots with a straight line. Hopefully you have a ruler with you, or use the edge of a book or something else that's straight, and add your arrows on the end, and you're done. That's all we're really looking at in this section. Just playing around with the Cartesian plane and graphing straight lines.